Hello, welcome to the Omega Virtual Learning. This is lesson 5 on vectors. And in this lesson, I'll be looking at two main vector problems: calculating missing ratio of vectors and calculating scalar of vectors. Question 1. Parallelogram OABC. We have vector OA as A and vector AB as C. So we check the information, everything is there, arrows in the right direction. If not, we have to do it ourselves. X is midpoint of line AC. So we need to first, that's our midpoint. Then OCD is a straight line. So that OC is to CD and K is to 1, which means that K represents OC and 1 represents CD. And because OCD is a straight line, then D lie ahead of C. Also, a K represents OC, so we have that. And 1 is CD. Okay. We've been given XD as a vector 3C minus half A. So that's the vector XD. We're supposed to find K. So what we need to do here is that we want to first establish CD vector in terms of K. Once we are able to do that, then we can work out vector XD using vector XC and CD. And the answer that we've got, we can equate it to the XD vector that's given to us and solve for K. So to start, I want to work out what is AC. Vector AC is vector AO plus vector OC. Vector AO is going against vector A, so it has to be negative A. So it's negative A plus C. Now, before I continue, I just want to work out what will be the component of 1 in terms of C and K. So I set up my ratio, OC and CD. K is to 1. But K represents C, so I put C under K. If C represents K, what will 1 be? Simple ratio rule, you multiply C times 1, which is C, and divide by K. So that means that the 1 actually represents C divided by K. So I put it there as well. Okay. So now I know the length of my AC. I know the vector CD in terms of C and K. I'm now going to work out the vector XD, which will be equal to vector XC plus vector CD. Okay. Now, XD is XC plus CD. We know CD according to this as C over K. All we need to work out is vector XC. XC is also half of vector AC. So AC is given to us as negative A plus C. Half of this will give us negative half A plus C. So I'm now replacing XC with all that, then plus C over K. So knowing this as SD, which we've just worked out, and knowing XD as given to us in the question, we can equate it to. And we solve for K. Minus half A is common to both sides, so we cross that out. We minus half C from both sides. So 3C minus half C is 5 over 2C. So we have CK equals 5 over 2C. And if we divide, if you cross multiply, K times 5C is 5CK. 2 times C is 2C. You can decide to cross the C out first, but if you don't understand it this way, just cross multiply. That's what you have. Divide through by 5C. If you divide through by 5C, this 5C will cross out the 5C. If we divide through by 5C, C will cross out C, leaving only K is equal to 2 over 5. Because if you divide through by C first, you have 5K equals 2C. If you divide through by 5, you have 2 over 5. So our K represents 2 over 5. Let's look at the next question. OMA, ONB, ABC, they are all straight lines. M is midpoint of OA. B is midpoint of AC. OA vector is 6A, vector OB 6B, vector ON is KB, and K is a scalar quantity. Given that MNC is a straight line, find the value of K. Right, so let's put information. ON is downwards, so the arrow should face downwards, 6A. OB is also downwards, and ON is also downwards, so that is done. Now, we know, because it says that B is midpoint, so it means that AB should be equals to BC. Now, it's also been given to us that MNC is a straight line. So to work out K, we can use the confirmation of straight line by saying that if that is so, then it means that vector MC should be a multiple of vector MN. And once we manage to do that, we'll be able to look at the components and actually know what is missing for the value of K. So that's what we're going to do. So given that MNC is a straight line, then MC must be a multiple of N. And that also means that at the end we can check the ratios of coefficients of MN and MC to work out K. We check the ratios or check the coefficients and see what should be the value of K. Sometimes you might need to form an equation if it is really in an expression form, but if it is really in terms of numbers, you can see it clearly. You don't have to form an equation. So we start, we know AB is equal to BC, so AC is equal to double AB. So let's work out what AB is. AB is vector AO plus OB. Vector AO is going against the vector 6A, so that is why it's negative 6A plus 6B, because this one is going along it, so it's the same. This one again going against the vector. And since AC is double 2AB, we can work out AC as negative 12 plus 12B. We just have to double vector AB. Now, we can now work out vector MN and vector MC. We start with vector MC. Vector MC is simply vector MA plus vector AC. That's what we have here. Vector MA is half of vector OA because M is midpoint of OA. That's why we have 3A. And we know AC already is what we calculated before, so it's minus 12A plus 12B. Let's simplify this. We have it as 3 into bracket negative 3A plus 4B. Actual answer is negative 9 plus 12B. Negative 9 plus 12B. But if you factor out, it's good to always leave your answer in simplest form so they can help you really go by the rules. So if you factor out 3, and that's what we got for MC. Let's work out MN. MN is MN, let's go the other route because we are trying to include the K. MN is MO plus vector ON. Vector MO is half of vector AO, and we are going against the vector. We are going against the vector, so it has to be negative 3A. So you have negative 3A plus KB. Negative 3A plus KB. Now, if you look at this carefully, it confirms that, yes, if it is really a straight line, you see we have negative 3 here, we have negative 3 here, and then A. We have a K, we don't know the value, and we have a B. For this to be really be a subset of MC, or for MC to be a multiple of MN, then this value must conform to what we have in the bracket here, because this is the multiple. So it shows that if you compare, this is minus 3, that is minus 3, then this must be equal to that. And therefore k is equal to 4. Also, if it were to be expression, if you want to set up an equation, the ratio of the coefficients should be equal. So the coefficient of a and a is negative 3 divided by negative 3. That's one side. Should equals to k over 4. And negative 3 over negative 3 equals k over 4. When you work it out, you still have it as k equals 4. So that is another way of doing it. A set up ratio of coefficients as equation, and you work it out, and the answer is the same. So our k is equal to 4. So that brings us to the end of lesson 5. I'm going to do an extension of lesson 5. I'll call it 5b, where I'll look at different exam questions on vector problem solving questions. And we'll also see another way of creating a proper equation where you will not have the answers in terms of numbers to compare, but it becomes an expression and you have to form an equation in order to solve for that scalar k. Thanks for watching and share with your friends.